Here are some frequently asked questions about CAFS. Isn't 90 GPM too little flow for interior firefighting? What about the Iowa State formula? The Iowa State formula is based on the application of water only, which according to the National Fire Information Center, or NIFC, in Boise, has a 10% efficiency rate in suppressing fire. CAFS changes the physical properties of water to make it several times more efficient at both cooling and smothering. The question isn't about raw GPM, but effective GPM. Would you rather get a 10% efficiency of 1,000 gallons or a 50% efficiency of 500 gallons? In a 1990 study in Oregon, NIFC found that 75 cents of every dollar paid out by insurance companies was for water damage, not direct fire damage. A 1994 study showed that the use of CAFS resulted in only 10 to 20% of the water damage considered normal. Don't other fire departments like Phoenix prohibit the use of CAFS for interior firefighting? Phoenix does not use the standard distinction between wet and dry CAFS in their policy. They rightly restrict the use of dry CAFS to defensive operations and overhaul. Neighboring Mesa, Los Angeles County, Boston, and many others all use CAFS for interior operations. In fact, of those departments utilizing CAFS, the overwhelming majority use wet CAFS for interior attack. Is kinking of the hose line a problem? The chance of kinking a hose is increased with CAFS. However, the line is far easier to maneuver due to the marked decrease in weight. Boston Fire ran with a 400-foot inch and 3/4 pre-connect during its studies, conducting fire attack on what would be the equivalent of several years of fires for the Spokane Valley. According to the Boston test, kinking of the hose was not a problem, as long as they paid attention to where they were going. It was a benefit when they wanted to extend the line because they could completely stop the flow to add hose by manually kinking the line. Is it true that your CAFS line can burn through if exposed to heat? Any line will burn through if excessively exposed to heat. There is a case, however, in Germany where a CAFS line did burn through with a crew on the line. It was found that at 396 degrees, a CAFS line would burn through faster than a non-CAFS line. If you review the details of that fire, however, you will see that extremely poor decisions were made throughout the incident. To blame the use of a CAFS line for the deaths of those firefighters would be much like blaming the use of ordinary seat belts for fatalities in a plane crash. What about having inexperienced firefighters at the pump or on the line? The use of CAFS is only authorized by individuals who have been trained and evaluated in its use. This applies to both pump operators and nozzlemen. Can CAFS be used on vehicle fires? Yes, CAFS can be used effectively on vehicle fires. You must remember that the 2007 Masterbody engines, however, do not flow Class B foam. When working with large, flammable liquid spills, Class B foam should be applied. What do I do if the pump engine goes down? As with any apparatus, you need to advise all crews you are supplying of the pump status. With the compressor set to auto rather than fixed, the CAFS air will not continue to flow at the same pressures. However, without water flowing, the compressor will quickly overheat unless shut down. Until an automatic failsafe is added to prevent this, you must immediately turn off the compressor PTO. What do I do if the compressor goes down? In our test, we turned off the compressor to see the effects on the line. We found the PSI at the discharge port automatically decreased to approximately 60 PSI, while the flow of water and foam increased to 120 GPM. This provides a good safety margin for crews on the lines. You still need to immediately notify the crews of the situation and make individual adjustments as requested. This may involve replacing the smoothbore tip with a fog tip or appropriately adjusting pressure and gating the line. The advantages of CAFS are many and include rapid knockdown through efficient steam conversion and smothering, reduced water use providing increased flow time of tank water, decreased rekindle potential through greater penetration and blanketing, high effectiveness at penetrating concealed spaces and voids, lighter, more maneuverable hose lines, reduction of toxic vapors through the application of a suppressive blanket, and the ability to protect exposures without the need for constant flow. The most commonly reported negative issues with CAFS are these. Foam can get on your mask and obscure vision. CAFS can be slippery to walk on and hide uneven ground. CAFS lines can kink more easily when backing or turning sharply. CAFS lines have the potential to burn through faster than a water line. All of these problems are easily mitigated. For instance, foam on your mask can simply be wiped off with a gloved hand. Experienced CAFS crews reported they quickly became accustomed to working on somewhat slippery or uneven ground. However, care should always be taken when walking through any fire scene. By maintaining the same number of personnel required to advance a water-only line, friction points and potential kinks are quickly mitigated. As for burn-through, care must be exercised in the placement of any line, and extreme care must be used when working above a fire. The structure in this CAFS demonstration was once a confinement shed for raising hogs. The building is a wood frame structure built in the late 1930s with asphalt shingles. The structure was full of miscellaneous items added to the fire load, including tar paper, wood crates, lumber, and various other combustible materials. The building dimensions are approximately 48 feet wide by 70 feet long, by an average height of 14 feet. Building with contents equaled an extremely high fuel load. The equipment used included a Darley auto CAFS system, a single 1 3/4 hose line 150 feet long, a task force tip with a 1.5 inch ball valve and an 1 1/4 tip, 60 GPM foam solution rate, and 60 CFM airflow at 100 psi. Notice the heavy black smoke and incipient stages of flashover immediately prior to introducing the CAFS fire stream. Watch closely as CAFS is introduced into the fire and the heavy black smoke quickly dissipates. The flames are quickly extinguished and amazingly knockdown occurred within 8 seconds of application. Less than 10 gallons of water was used. The focus of this exercise was to demonstrate the effectiveness of a CAFS stream when applied to burning tires. There were 12 automobile tires that were placed in a pyramid fashion with 5 gallons of diesel fuel applied. The tires were allowed a 5-minute pre-burn. Application was done with the Darley auto CAFS system at a 0.5% Class A foam solution flow rate. Application rate was 20 GPM at 60 CFM to create a heavy-bodied blankety type foam. Suppression was done in approximately 30 seconds using a mere 10 gallons of water foam solution. This concludes the video portion of your training on the 2007 Masterbody CAFS system. Be sure to get plenty of hands-on practice using the actual systems. And remember, you must be evaluated prior to using CAFS on an actual incident. Also remember that CAFS may not be appropriate for use on every incident. Rely on your training, experience, and common sense to be effective and keep you safe.